Section 3.1 to 3.2 review. Calculators still are not allowed, and this is number 4. There's only one variation, so it's important that you understand how this process works, because the same process will come into play on the exam. It tells us that f and g are differentiable functions, and then I give you two different properties for those functions. The first property is that g is always positive, so the outputs of g are always going to be above the x-axis. And then I give you a single point on f. I tell you that if I plug 0 into f, I'm going to get a 3 out. Now, using these properties, we now want to use this information and put it all together to figure out what f actually equals. So here I've defined a third function, h of x, as f times g. And then I told you what the derivative of that h is equal to. Now, because h is defined as a product, I can use my product rule to take the derivative, and perhaps that will give me a relationship between the derivative I can find by hand and the derivative that was given to me. So let's do that. If I take the derivative using the product rule, I can see that I have my first function times the derivative of my second function plus my second function times the derivative of my first function. So here I've got an expression for h prime of x that involves two distinct terms. But if I look up at what was given to me, that derivative is only equal to one term. So I have two different variations of what h prime is going to equal. So because they have to be the same, notice they have this term in common, but the one that I was given is missing this. Because it's missing it, that means it has to equal 0. So I have this g of x times f prime of x has to equal 0. Okay, so this gives us some information. If we remember our old zero product property from our algebra class, we know that if we have two things that multiply together to give me 0, then either the first one has to be 0 or the second one has to be 0. So let's look at what we have here. This one says g of x equals 0, but if I come up to the given properties, g of x can't equal 0. It's always positive, so this is not an option. That means my only remaining option is for the derivative of f to always be 0. So what kinds of functions have derivatives or tangent slopes that are always 0? Well, if you think about it, they are constant functions. Constant functions always have horizontal tangents that are equal to 0. So that means we can write that the original function f has to be some sort of constant. To figure out what that constant is, we go back to our item 2 that was given, and this told us that if I plugged a 0 in, I got a 3 out. Because I got a 3 out at this point, then I have to get a 3 out at every point. So my conclusion is that f of x is equal to 3.